All right, good morning, everyone, and welcome to Yale University's Jackson Institute for Global Affairs. I'm Ted Wittenstein, Executive Director of International Security Studies, and we're delighted to kick off our final day of this semester's Yale Cyber Leadership Forum focused on bridging the divide in artificial intelligence. A few quick housekeeping announcements. I just want to acknowledge and thank Emily Roback and her team who've brought us to day 3 here of the forum and made this all work possible despite the pandemic. These are interactive sessions for those of us in the in-person audience as well as online. So if you are viewing us virtually, you can submit your Q&A using the Q&A feature to the right of your screen. Virtual attendees have their volume and video muted, but you can, we're monitoring those questions. We'll incorporate them as we go. And of course, we are recording this session and we will distribute and post the video afterwards for the benefit of everyone. As mentioned, this is the final day of our 3 half-day Fridays that have taken place this semester. We've featured more than a dozen Yale faculty members across multiple schools, departments, and programs at Yale, joined by other special guests, including today especially. We've focused on bridging the divide among the law, technology, policy, business, and academic communities, really focused on 3 core areas where AI already is posing significant cybersecurity concerns, including big data, data privacy, and AI governance. That was our first session. Our last session, most recently, was disinformation and the future of democracy. And of course, today we'll focus on AI ethics and safety. It's always a pleasure to partner with the Yale Law School Center for Global Legal Challenges, especially with Professor Ona Hathaway, who's been a colleague of mine as we've built this forum over the past few years. We're especially thankful to our sponsors, including knowledge partner SAP, who's really been able to provide support to make this forum so accessible to everyone in virtual audience. Ona Hathaway has been our forum director since the program's inception. She's the Gerard C. and Bernice Latrobe Smith Professor of International Law, Director of the Yale Law School's Center for Global Legal Challenges, a faculty member at the Jackson Institute. So thank you so much, Ona, for all you've done to make this forum possible. I'm going to let her introduce our first session. So as a reminder, this panel will run until about 10:15. We'll take a break for coffee. The second panel will start at 10:30, followed by lunch. So thank you so much, and over to you, Ona.
Thanks so much, Ted. It's a pleasure to be here, and we're so lucky to have an amazing group of panelists here to talk with us about our topic, AI ethics and safety, and particularly this first panel this morning is going to focus on technical safety research and trust in AI. And we have an amazing group here to help us navigate this space. So to my immediate right, Elena Kochko currently serves as Chief Trust Officer at SAP, who's one of the sponsors of this program. It's a multinational software corporation that's based in Germany with worldwide operations. Her team spans 4 continents. And it enables, as she puts it, the trustful, secure digital transformation of clients across global lines of business and cloud products. Elena has been participating in this forum, I think, close to since its inception. So we've been lucky to have her since the very first session. So we've been very lucky to have her as part of this conversation through many years and through her many hops through elite areas of cybersecurity. So before joining SAP, she was Chief Operating Officer, Senior Vice President and Technology Executive and Global Security Organization at Bank of America. And before that, she served as Chief Information Officer in the Global Security Division at Barclays Bank in New York and London. So she has a range of experiences, which we're really lucky to get a chance to learn from today. Next, Andi Peng is a Ph.D. student at MIT. In computer science and artificial intelligence, working in the Artificial Intelligence Laboratory. She's broadly interested in how adaptive learning emerges. She received her BS in Cognitive Science and BA in Global Affairs here at Yale. She spent 2 years as an AI resident at the Adaptive Systems and Interaction Group at Microsoft Research, and she's worked at the White House Office of Science and Technology Policy with partnership on AI and Schmidt Futures on understanding impacts of technology, And she also serves on the advisory board of the Yale-Jackson School of Global Affairs. Drago Radev is the A. Bartlett Giamatti Professor of Computer Science here at Yale University. His research interests are in natural learning processing, information retrieval, machine learning, and artificial intelligence. He's currently working on lexical semantics, sentiment analysis, question answering, text summarization, deep learning, and dialogue systems. I'm assuming he'll tell us a little bit about what all of that means, as well as the application of NLP to the humanities, social sciences, and bioinformatics. He has more than 200 international publications, as well as 3 patents. And to moderate our session today, we're lucky to have Ted Wittenstein back. He is a lecturer at Yale University's Jackson Institute for Global Affairs and Executive Director of Information Security Studies, a new research hub at Jackson dedicated to international history, grand strategy, and global security. Ted teaches undergraduate, graduate, and law courses on intelligence, cybersecurity, and national security decision-making, including the course connected to this forum. So many of the students who are here in the room are taking an undergraduate course on cybersecurity, and there are a number of law students who are enrolled in that as well as a number of law students who are taking a 1-credit version of this for attending the forum. So he is bringing the classroom into this conversation in a really valuable way. He's a graduate of Yale College and Yale Law School, and prior to returning to work at Yale, he held a variety of positions at the U.S. Department of Defense, Commission on Intelligence Capabilities of the United States regarding weapons and mass destruction, the Office of Director of National Intelligence, and the Department of State. So he brings a wealth of experience in Washington as well, working on a range of important policy issues. So I'm going to turn it over to Ted to moderate the session. We're so glad to have you all here, and we look forward to the conversation.
Thank you so much, Ona. Really looking forward to this session on technical safety research in trust and AI. We have the benefit of some extraordinary technical expertise this morning. So I've actually asked, starting with Professor Radev, an opportunity for Drago to just tell us a little bit about what he's doing as director of the Language, Information, and Learning Lab in the Department of Computer Science. It's a great acronym, Lily, happens to be my daughter's own name. And you really are, Drago, just engaged in some exceptional research projects looking at natural language processing. This is, of course, a critical component of AI in terms of how to understand human language as it's spoken and written. And I've asked Drago to just sort of give us a short sort of demonstration with a few illustrative slides that help us understand the current state of the field. So how advanced is AI becoming, or has it already become, with respect to NLP? Things like text summarization, logical reasoning, dialogue comprehension. These are just a few of the areas where Drago's lab is developing novel techniques. So just give us a sense of the state now of the field and what you're working on in the lab. What are some of the key questions that you think might bring NLP to sort of the next level of widespread, societal use? So thank you so much.
Yeah, thank you, Ted. So welcome. It is my pleasure to talk a little bit about natural language processing. As Ted mentioned, this is my area of research. So natural language processing is a key component of artificial intelligence. And some people even think that this is the most important part of artificial intelligence, because if you cannot build a robot or a system that can understand human language, it's probably not that intelligent. So that's what I think NLP is and what it will be. Now, for the last 20 years or so, people working in NLP have mostly focused on statistical methods and try to build better systems that can, let's say, summarize text, answer questions, engage in dialogue, and so on. However, over the last few years, maybe 5 or 4 years, people have started to focus a lot more on the societal and ethical issues associated with natural language processing. And I'm going to show you a few slides about my own research, and then also about the state of the art in the field and some of the risks that are associated with natural language processing. So very quick overview. I understand that not everybody here is a computer scientist. So in machine learning, what we do is we build a system that can look at examples. So instead of teaching it how to write a program and to use that program to solve some task, we give it inputs. So we say, for example, 8 times 4 is equal to 32. 11 times 5 is 55. And then we want the system itself to find out the code that will solve this task in the future and learn from those examples. One of the key components of natural language processing is something called word embeddings. So every word or every token in a text is represented as some n-dimensional vector. Usually n is on the order of 100 to 1,000 numbers. So believe it or not, this is the representation here for the word pharmaceuticals using the so-called GLOVE or global word embedding. So it's just 300 numbers that have really no meaning at all, right, if you just look at them in isolation. What's important, however, is when you look at those words in the context of other words. So for example, if you take the word embedding for the word tires and the word embedding for Michelin in some vector space, you realize that there's a transformation of this black vector here, which is going to take the embedding for tires and convert it into the embedding for Michelin. But then the exact same transformation can be applied to the word pharmaceuticals, and then you get Pfizer. So the idea is that in this vector space, you have semantics, and the semantic information is compositional. So you can have vectors that correspond to different pieces of the meaning of a sentence and put them together and understand the meaning of the entire sentence. So one of the most interesting ideas in natural language processing in the last 10 years or so has been text-to-text translation. That sounds a little bit geeky, but it actually is one of the most important methodologies for natural language processing. So here's how it works. You have some input text. Let's look at this first example here, like une pièce de théâtre, which in French means a play, like a theater play. You encode each of those words here, using word embeddings, and then you put them in a sequence and you pass information along this line until you get to the end of the sentence, and then you start producing some output in some autoregressive way. So as soon as you produce the first word of the output, you feed this word into the input, and then you produce the second word, and so on. Now, interestingly enough, the same exact technology, it was only very easy for me to just draw the same picture 4 times and not just once. It can be used for 4 different technologies. You can do machine translation, like in this example, we translate French to English. You can also do it to generate some text. You give a prompt to the system and say something like, and then Harry Potter, ... and the system says, flew away. You can also use it for dialogue. So you have a user who says something like, here is your receipt, and then end of sentence, and then the other user says, thank you. And then finally, you have here some summarization example. So instead of saying a long sentence or a long phrase about of influenza, you want to say it in a shorter way, like it's the flu. So as you can see, all of those 4 use the exact same underlying machinery. So one of the projects that I've been working on for the last few years is called semantic parsing for dialogue. So in semantic parsing for dialogue, we have multiple users who engage in some sort of a dialogue, as the name suggests, and they ask questions. For example, which European countries have some players who won the Australian Open at least 3 times? So this is a natural language question, which, just like the same as the previous slide, has to be translated from one type of text, namely English, to another type of text, namely SQL, which is the structured query language used to query relational databases. And you can see this is actually a very tricky thing, because the question here involves multiple inputs. So the text in red comes from some values in the table. The text in yellow comes from the names of the tables. Green comes from the names of the columns or the attributes of the records, and so on and so forth. So the translation system has to take into account both the input text, encode it appropriately, but also encode the content of the entire database, and then be able to translate one into the other. And then if you put this in a dialogue context, you can have an actual dialogue which has a certain task to achieve, for example, to reserve an airline ticket. And you have to do this exactly the same way by translating every utterance from natural language to SQL and back. So to put this in perspective, this is the exact same picture that I showed you earlier. And now we're translating English text or natural language text into some SQL query. So the other project that I've been working on recently, interestingly enough, it's in partnership with several big companies like Microsoft and Facebook. So this is a project on meeting summarization. As you can imagine, companies have a lot of meetings, and then people miss sometimes those meetings and they want to see what happened. So we've been working on a large data set that consists of meeting minutes and discussions, and then the questions that people who miss the meetings ask later on. Now, it turns out that you cannot just rewind the entire meeting and watch it from the beginning, because that kind of defeats the purpose. So instead, what we want to do is to summarize it automatically. So instead of having to watch, let's say, an hour's worth of a meeting, you want to watch just a short snippet. So it turns out that this creates problems. So whenever you summarize dialogue or meetings, you end up introducing some inconsistencies. So here, for example, you can have a very small dialogue here between two people, Hannah and Amanda, who are trying to achieve a certain goal. Then if you generate a summary automatically from this kind of text, you see that the summary contains some misleading information. It has the wrong reference. So they're asking one person to do something, but the summary says that they actually asked a different person. So obviously this is completely misleading and has to be avoided. You can also have a tense, like grammatical tense and modality error. So here the summary refers to some event that actually already happened, but it refers to it in the future tense. So again, that is a mistake that you want to address. And finally, you can also have a lot of other different types of misinformation that appear in the summary. And obviously you have to mitigate this in order to have the summary be very helpful. Now let's put this in the context of the industry in general. So Google has very recently, as in like last week, started introducing summarization, their own technology for summarization into Google Docs. So you can create a Google Doc like the one on the right, and there is a button here that says summary, and then the system would produce a short summary of your document. So this is done, by the way, using the transformer technology, which is a state-of-the-art translation, like text-to-text translation system. I'll explain in just a minute what it looks like. So currently, in like 2022, almost all NLP tasks are solved using something called pre-trained language models. You may have heard of those. The most famous one right now is called GPT-3 from OpenAI. If you are not familiar with it, I suggest that you go to that website, just Google GPT-3, and then you can play with it. You can ask it to do things for you. For example, here's a prompt, finish the story, or here's a question, give me an answer, or here's an analogy, here's a bunch of analogies. Now, can you solve those additional analogies using, the examples that I just showed you? So this field has evolved very quickly in the last 9 to 10 years. So starting from around 2013, when Tomáš Mikulov, who by the way was a PhD student in Brno Institute of Technology in the Czech Republic at the time, came up with this algorithm called word2vec, which is one of the fundamental algorithms for word embeddings. And then as you can see, the field has exploded over the last 9 years. The glove embeddings from Stanford came out the next year. And then attention, which is the most fundamental idea in modern NLP, was introduced 2015. Then the transformer was introduced by Ashish Vaswani and his colleagues. Then BERT. BERT is the most important language model in natural language processing right now. It is used to do anything from summarization and question answering to dialogue, named entity recognition, and sentiment analysis, and so on. Now, as you can see, the size of those models is enormous. So BERT itself was created only about 4 years ago, and it had 340 million parameters. And then just a couple of years later, GPT-3, which is again one of the most well-known examples, has 175 billion parameters. And now we're getting to the point where the most recent Google model called Google Switch has 1.6 trillion parameters. You can see how fast this field has evolved. Just over the course of about 3.5 years, it has gone up by 3 orders of magnitude. And just as a comparison, the human brain has about 85 billion neurons. So this is the kind of magnitude that we're talking about. Okay. So here's what GPT-3 can do. You can give it a prompt, like here you have some story description, and then it will generate an entire story for you. Now you probably see where I'm going with this. If you can ask the computer to generate a story, it's very easy to ask it to generate a fake story, and a story that achieves a certain ideological or political purpose. So GPT-3 is amazing. It has the best performance of all models in the history on a variety of NLP tasks, including, as I mentioned, question answering tasks, but also interesting tasks like the so-called Winograd challenge. So the Winograd challenge is where you have a sentence that says something like this. I went to the bookstore because I wanted to buy a blank. And then you want the system to predict book, or something that makes sense in the context of the sentence. But in order to figure this out, the system has to look at the entire sentence, go all the way back to the word bookstore, and then figure out that there's some semantic connection between bookstore and book. And if you change that word from bookstore to grocery store, then the system will have to complete it with something different, maybe olive oil or potatoes or something like that. So we had a paper literally accepted yesterday as part of a big corporation with a company called Big Science. It's part of Hugging Face. It's a startup in New York. I don't know if you're familiar with it. It's one of the up and coming companies in this field. And we analyzed a large number of data sets that have been used to pre-train language models. And it turns out that there's a major language imbalance. So most of the models that we are dealing with are trained on English and only on certain types of English. So there are some major language models that are trained on Chinese and a few others on other languages. The majority of the 7,000 languages in the world are really not represented in this. So this is a very important red flag that people have noted and are trying to address. I mean, another problem with those pre-trained language models is that they can introduce all kinds of biases and hate speech, for example. If you look at the adjectives that are mostly associated with different genders, you will see that there are some stereotypical associations that have come from the fact that you're training on data sets that some of them come from many years ago, from many different types of text. Now, I'm only going to spend a couple more minutes. So there are many sources of concern that people have to address. I'll just mention a few. So that those language models just memorize text in some sense. They can do some clever things with it, but they don't really understand the underlying text. So there's no internal model of the world, as Melanie Mitchell has written recently. They have basic problems with common sense, like basic physics, like can you fit an elephant in a matchbox, you know, that sort of thing. They have problems with that. Their decisions are not interpretable. So the system can tell you something, but you don't know why and how it arrived at that answer. They can have biased output, as I mentioned. They can be toxic quite a lot. In fact, there was a company, I wouldn't mention which one, which a few years introduced one of those models, and then within a few hours, it started generating Nazi propaganda. That's how bad it is. They had to shut it down like 4 hours after they started. So those models can be used to impersonate people. They can be used for spam and for phishing, to generate misinformation and deep fakes. There's a very interesting research paper from OpenAI, which I can probably share my slides, people can look at it. You can find out that there are all kinds of socially harmful activity that can be generated from text, and that has to be addressed, understood, and mitigated. I mean, to summarize the slide, this kind of technology is obviously dual use. It can be used as a blessing, but it can also be used as a weapon. And this is all obviously balanced against progress in NLP. I mean, somebody will say, why don't we just ban research on natural language processing and pre-trained language models? That's not going to happen. Just like, you cannot ban research into computers or the internet. I mean, those have too many positive outcomes in addition to the negative outcomes. So deep fakes, as you know, is an important issue in video. I think there was a discussion in this panel a few weeks ago on video deep fakes. In fact, very recently, there was a fairly well-known fake video from Volodymyr Zelensky, the president of Ukraine, who apparently was surrendering to the Russian army and so on. That was a complete fake, with many TV stations and internet outlets, broadcast this video until they found out that it was a fake. So you can imagine how much of an effect this can have on like the morale of an army or the population of a certain country. And one more example, the Wall Street Journal has reported that a majority of the comments sent to the Federal Communications Commission are fake. So they're generated by bots, and then the people who try to promote a certain position, post them, and then it's very difficult to tell which one is which. And you can generate fake news. I started this last night, and I asked to write a story about Ted Wittenstein, and I found out that he went to Tufts University and to Syracuse University, which I understand is probably not true because he went to Yale. Now, last few slides. So there's a very interesting paper from MIT Media Lab, which shows that people actually are very susceptible to text fakes. When they were given text fakes, they were only able to figure out that they were fake about less than 50% of the time. And this was worse than video, both video with speech and video without speech. So there are many proposed solutions. There are two categories of them. Some of them have to do with mitigating the generation of bad information. For example, training on cleaner data. So the most recent GPT model is trained only on documents that are from the web, but that have somehow been vetted as being high quality documents by having high karma points on Reddit. That's one of the criteria that people can use. You can also only release a small version of the model so that people don't abuse it. It can generate much worse things with the larger model than with the smaller model. You can also use automatic techniques for debiasing, detoxification, and so on. Now, the second half of the slide is about things that you can do at the societal level. For example, you can have rules of use. So OpenAI has very specific rules. When you generate some text, it asks you to check if it has toxic text in it and warns you how to use it and when not to use it. You can educate the public to spot outputs of synthetic media. There is also some legal framework that probably has to be put in place to have some serious penalties for misuse. Also, to understand the whole problem is very important to be vigilant about it. Okay, so the next few slides I'm going to skip just to tell you there was a very interesting report from the Department of Homeland Security very recently where they talked about the increasing threat of deepfake identities. They came up with those 10 different serious issues, and as you can see, some of them are pretty bad. So you can have deepfake kidnapping. So pretend that you kidnap somebody, and then send some text from them, and then try to get a ransom. And also really horrible things like cyberbullying, deepfake pornography, election influence, and so on and so forth. And they have also some suggestions how to address some of those. So the last thing that I want to mention is that I've recently become part of this project called Big Science, which again is run by Hugging Face, but it involves about 900 researchers from around the world, 50 different countries. So our goal is to build the largest pre-trained language model that is trained on as clean text as possible and to have very clear ethical and governance decisions involved in the process. So this is something that is happening right now, and we just got some of those papers accepted. I mentioned one of them just a few minutes ago. And then we also have recently had a paper accepted on prompt engineering, essentially how to come up with prompts that can solve different NLP tasks efficiently. That's it. Thank you.
Thank you so much, Drago. That was a great overview, and I have a lot of notes here, and want to come back to you in particular on your areas of concern as well as your potential solutions. I'm just going to incorporate a few thoughts quickly as well from Andi and Elena, and then we'll sort of get into a conversation. So Andi, I wanted to give you an opportunity to react to some of Drago's presentation, as well as share some of the own research that you're doing, less of course in the natural language processing area, but as a PhD candidate at MIT at the Computer Science and Artificial Intelligence Lab of Embodied Intelligence, you're working on this concept of adaptive learning. And so I was wondering if you might just want to share a little bit about some of this, in particular, sort of help us understand what adaptive learning is, help us sort of get a better grip on human-like planning, reasoning, and shifting environments. You have a robotics background and originally from your time at Yale. So it's less in the language processing area, but it's many of the common themes as it relates to AI. And so I was wondering if you might just briefly give us a sense of some of that work as well.
Sure, thanks, Ted. First of all, it's kind of a huge honor for me to be invited back to my undergrad institution to be next to, I guess, an old professor of mine in many ways. And for those of you who made the trek up to Greenberg from Central Campus, I know it's no small feat for Friday at 9 a.m. So thank you guys for being here. Yeah, so as Ted mentioned, I work in the area, I think that the key phrase there was embodied intelligence. So Drago had just mentioned a lot of what we think about in terms of language. Language models are oftentimes what we consider non-embodied intelligence. Language models exist in the realm of virtual, I guess, interaction. Now, the key to, I guess, when we think about artificial general intelligence comes when we have a physical being deployed in the world, when we think about robotics, right? First of all, the problem changes in two different ways. One, when you train something in simulation and deploy it in the real world, you encounter all sorts of shifts that may occur in the environment. So all of a sudden you've got things like friction, like rain, like weather, like pesky humans that change their minds at all times, messing up your system that otherwise would be trained for one specific type of interaction. And so I think the first key component of understanding why we might need to care about embodiment is knowing that the world is different than what we think about it in a computer. And the second part I think that's important to mention is that when you also move to the realm of, I guess, AGI, all of a sudden your problem becomes sequential in nature. You don't think about training to interact with one person or a particular interaction. You think about it as a continuous stream of interaction. I put a robot into the world, it does some stuff, a human does some stuff, the environment does some stuff. All of a sudden, the robot needs to learn how to adapt to whatever behaviors it's encountering in the environment. And so as a result, we also see sorts of these continuous shifts that we need to employ in kind of an adaptive learning setting. I also included some slides.
Yes,
I was wondering if those might be projected.
Up here in a second. Great.
Yeah, so I will briefly, I guess, talk about, I'll briefly include a graphic for an example, and then we'll move on to kind of a continuous setting to talk about why this might matter. So if we think about the way, like in practice, an AI-aided decision task might actually be used in the world.
You want next slide?
Yes, next slide,
Okay,
please. Yeah, so traditionally what we think of is we've got this trained machine learning model. It's like doing some stuff. We as a designer, or me as a designer has said, please go fetch a cup, or please go recommend to me potentially a job candidate for hire. The model is going to train on this very specific objective that I proposed, and it's going to learn how to do that in the form of a neural network. And then ultimately, this model is going to spit out a bunch of predictions that are going to then be in the world for us to use. Next slide. So in this particular kind of sequence of interaction is where we think about a lot of the current work in algorithmic performance and bias to kind of lie. When you hear a lot about we want to train our models to mitigate biases, this is kind of the loop that we're talking about here. How in the training process can we think about, I guess, mitigating a lot of these undesired intended consequences of these models? Next slide. However, I think a paradigm that we don't often consider when we think about deployment of systems is that ultimately this thing is not a closed form loop. We're going to put it into the world where it's going to have to interact with a human. And ultimately in the form of a decision task, the human is going to be the one that needs to understand how we integrate all of these model predictions together to make kind of a cohesive, collaborative teamwork decision. Next slide. So something that I think we need to consider from a social perspective when talking about deploying these systems is how human performance and bias, when we're interfacing with our trained AI systems, need to work. And so not only are we thinking about the machine learning biases, we need to also think about how all of this loop percolates down throughout the decision system. Next slide. And so it's very much in this interaction here that I think about a lot of the upcoming work that needs to occur in our field with respect to adaptive learning, which is now take this and put it in sequence, right? I've as of now described one single interaction. When a machine learning model, a robot, whatever you want to call it, does one thing, the human decides to use that prediction or that recommendation to do one more thing. And already we see in one closed form interaction all the different problems that may arise when we're thinking about deploying a system. Now, imagine repeating the sequence over and over and over again in the context of a robot in a home, right? For me, I think what would probably give me a Turing Award prize or like a Nobel Prize is me being able to put a robot in a house and having it like literally do anything that we wanted to do. That is how far in the field we are away from having a model that can over time interact reliably and consistently with a human. And so I guess my work and what I think is going to be really important in the field moving forward is thinking about how, as we deploy trained models into the environment, and we have shifting environments with both the human and or the actual physical space we're in ourselves, how this entire closed form loop can learn to adapt over time such that our systems don't fail in the real world in the way that we can kind of hope for them not to in simulation. So definitely important questions here with language and how we interface with the robots, but the robots themselves in the world as a physical form is something that I'm really concerned about getting right.
Thank you so much, Andi. Really interesting contrast there of the language in the virtual world versus the physical challenges of robotics. And so we'll get to that dynamic in a second. And I wanted to bring in Elena, who of course is Chief Trust Officer at SAP, and you're overseeing a team a large team worldwide that's looking at sort of trustful, secure digital activity of clients. And so how do you think of trust from a sort of cybersecurity, information security officer vantage point? Now, of course, some of the tools that we were just talking about are not yet widely utilized yet in SAP systems, although you are starting to see, of course, machine learning, text, voice recognition, facial recognition. These are tools that are already being deployed in major companies. And so, how do you think of the risks associated with emerging technologies, when to utilize them, how to build them into your business model, how to support future research in this area that could be useful? And we welcome your thoughts from a private sector perspective.
Absolutely. Well, thank you so much. Thank you, Ted. And as Ona mentioned in the beginning, it is my honor and pleasure to be back on campus as well. I've been part of the Yale Cyber Leadership Forum since the beginning, since the very first one. And it's an honor for us to be a partner to this year's forum as well. I've also prepared some slides to walk you through how we think about digital trust, what trust means, how we measure that, what are the risks associated with that. Next slide. If lifeblood of the digital economy is data, its heart is digital trust. Next slide. What is actually trust in digital technology, and how do we define that? On the next slide, you can see that I summarized it in several buckets. And for me, trust and the way we define it in our organization is the confidence that the commitment will be kept. I am the chief trust officer of SAP. I'm building the organization. And for us, it's very exciting to see that this is an area that's evolving and growing, and more companies are looking into this. So it's very interesting for us to see how do we actually define that. Well, first of all, trust consists of being able to explain how and why companies do what they do. A core fundamental of trust is engaging with customers, and of course, connecting and showing them their humanity. This is, we believe, are the core actions that we need to, as corporations, to take to be able to gain customer trust. Next slide. What are the challenges, to Ted's point, to building customer trust? And of course, cybersecurity is something that we pay very close attention to. So today's threat landscape poses a number of challenges. On the next slide, I've summarized some of just the key facts for you to refresh, the memories, and just to see the scale against which we're up. So 36 billion of records exposed by data breaches, over half of them and contained personal, sensitive, confidential information. We're seeing a large growth in ransomware attacks, especially during the pandemic. Millions and millions of new phishing and scam pages are created, to Dragos and Andy's point, and fake news and all of how easy it is to generate. With that, 68% of business leaders feel that cybersecurity risks are increasing, and they're not necessarily fully prepared for that. The average cost of a data breach continues to rise. And then, of course, most of the organizations experience the impact of that, whether it's a ransomware attack or phishing attempts, and we know that 90% of the breaches, or over 90%, start with a phishing email. On the next slide, I've summarized what are actually the core, most vulnerable and most attacked industries that really need to focus on building trust. Education is on top of that list as well. But in addition to education industry, it's small businesses, government agencies, specifically, municipalities and local governments that might not have a lot of cybersecurity capabilities, energy and utility companies, critical infrastructure, healthcare, and financial institutions. So what is actually the state of trust in 2022? Next slide, and then the slide after. Here are some of the statistics that I was able to find to showcase for you what the state of trust is. Technology is considered one of the most trusted industries right now. It's very interesting. With that, we see that the trust in technology continues to decrease. We saw, according to the surveys that we saw, a 5% decrease over the last decade. A lot of respondents believe that technology is changing too fast, so they're not able to keep up with all of the changes. There are concerns that were raised about the future of work due to automation. And we can also discuss, if those came true or not. A lot of the data that we're looking at right now shows that actually more jobs are emerging. We're expecting that global GDP can rise by almost 14% thanks to the new technologies that Drago and Andi alluded to, and many more. And then, of course, technology develops much faster than we have frameworks for or benchmarks of. So governments can't regulate those fast enough. And it falls to companies like ours or other institutions to develop their own principles and guidelines according to which they will be operating and what they will actually be developing. At SAP, we do have a global AI ethics policy. We have an AI ethics steering committee, and we are guided by those principles. So I'm happy to share, if you're interested, what actually is included in those principles and what actually is included in our policy. And then next slide. So the state of cybersecurity is a core fundamental aspect of building trust. On the next slide, I've summarized the challenges that I was also asked to describe for you in the cybersecurity sector, especially that we've seen over the last 2 years during the pandemic. Remote workforce, that presents a new attack vector. We went from the world where 80% of the work was done in person in the offices to where 80% of the work, 80% of the workforce delivers 100% of the work remotely. So basically, that just shows you the complete change of the landscape. And of course, a lot of companies, including ours, embracing those remote work opportunities as a competitive advantage. Staffing shortages and skills gaps. We do know that over 3 million jobs are going unfilled in the U.S. alone. Yesterday, I was telling Ted, we were in the news. We saw the new numbers that over 50% of cybersecurity workforce is above the age of 35. So we're very much looking forward to partnering with institutions and universities. We, in my team, for instance, we opened unlimited internship opportunities in every major U.S. city. That we're looking for talent that can join our industry and sector. We do see still lack of cybersecurity knowledge and uneven regulations. On the next slide, I've summarized again some of the numbers. 3.5 million jobs are going to be unfilled. 95% of cybersecurity professionals reported skill shortages, and it hasn't improved. Most organizations, over 76%, reported difficulties in finding cybersecurity specialists. And some, of course, leaders believe that not everyone, they're not able to provide proper trainings to every single person in their team. So that's just some of the factors and challenges that I was asked about. On the next slide, I've put together some numbers on the future of cybersecurity. The scale of the damage from cybercrime, the scale of the data that's going to be available to the organizations. By 2025, 60% of organizations will use cybersecurity risk as a factor in conducting third-party transactions and working with third-party providers and vendors. Next slide. So what can we do operationally, from the practical standpoint to foster trust in technology? And here are some of the examples that I was able to find, and I'm happy to quote on what can companies do. For instance, a smartphone manufacturer provides detailed information about how they store customer data. A software provider updates their features after receiving feedback from customers. They collect that information, they update the features, and they inform the customers back. Addressing a data breach and informing affected customers. That's actually, sorry, can you go to the next slide? That became part of the laws and regulations as well. Being conscious of avoiding biases when you're training data and developing AI technology, which of course my fellow panelists have covered extensively. And then allowing customers to opt out of sharing data with third-party providers. So for instance, in my company, I can give you an example. We built a portal. It's called SAP Trust Center and My Trust Center for authenticated customers, where we provide them a one-stop shop on all the matters concerning cybersecurity, privacy, compliance. We're automating access to a lot of those information, automating requests that we're receiving from customers in thousands. So definitely looking for more ways on how we can automate trust, looking for good research ideas if you have. Definitely, very open to feedback as well. And as I mentioned, just from the SAP perspective, we do have the AI policy. We have business units focused on embedded AI. We're providing customers with individual AI microservices as well as tools that they can use to build their own AI projects, which we're happy about. And there's some business leaders, actually CEOs of very big companies, that have said that AI will be more transformative to the world than electricity was. And then to Ted's last point on the next slide, I've summarized some of the questions that we as business community would like to ask back of the research community where we need help. So we don't have just the opportunity to dive deeper into those aspects, but on the next slide, actually on this slide and the next one, I've summarized almost 2 pages of questions on how we can measure trust. Do you think we can identify triggers that change trust? How do we automate trust? How can companies stand out by using trust? How can we sustain it? Because we know it also changes just depending on the news, So how can we sustain that and stay ahead of that? What are the trends? How do we use our, cyber vendor ratings or NIST scores that affect cybersecurity premiums? How do we use that to build bigger trust with our communities? What do customers value in tech companies? How is transparency that we're building through a lot of the efforts that my team is putting in place? Is that enough to gain and maintain trust, or is there something more that we should be thinking about? How do we establish trust in innovative technologies? And what role does trust play in resilience? So I'm happy to share those questions that I put together. If you're looking for paper ideas or dissertation topics, and we'll be very happy to partner with you and do those joint projects.
Great. Thank you so much, Elena. Drago, I wanted to go back to you and just maybe turn some of these research community questions from Elena back on you, particularly this one of sort of measuring or automating trust, because I think part of your presentation really kind of highlighted both the just extraordinary and exciting research that you and your lab are doing on NLP, but also a lot of the uncertainties and vulnerabilities that are still out there, whether it's the deep fake text, which would be obviously one that would be maliciously or intentionally created, but you also highlight just a wide range of toxic biased language, unintended consequences, lack of explainability. So what are some of the most promising venues of research in your mind where you can sort of start to bring about enhancing trust in the text, if we are going to sort of reach a place where we might be really using wide-scale societal use of NLP? What are some of the most promising avenues that might help enhance trust in this area, in your view?
Well, this is actually a very interesting question. Unfortunately, we are now at a stage where the good guys haven't yet figured out how to have trust, how to create trust. So when Google and OpenAI have a problem, making sure that the models that they create are reliable, we cannot count on the bad guys doing it at all. So on the good guys side, at least people are trying to train on cleaner data, to have much more transparency, better data governance, focus on fairness and ethics in the process. But that's not going to stop some bad actors from, misusing this. Now, on the mitigation side, I think that it's very difficult, again, just like any sort of adversarial activities like viruses and spam and so on, just because the bad people would always adapt and come up with a new way in which they can do harm, especially when they're motivated for like political, ideological, or monetary reasons. I mean, some of the ways that you can maybe mitigate some of this is to be aware of all the risks and to educate the public to understand better when you have, fake text or fake videos. Also to have some reporting mechanism where people can share, their opinions, their belief about those outputs.
Thank you. This, of course, came up in our previous forum session on disinformation and democracy, sort of a need to create greater education and human perception understanding beyond the technical tools in order to aid our understanding of disinformation. And, I want to bring you in, Andi, because not only do you have obviously extraordinary technical skills and research that you're currently doing at MIT, but you also have this background in that you've worked at the White House Office of Science and Technology Policy, Partnership for AI, Schmidt Futures. You've been involved in a number of sort of nonprofit as well as public sector organizations that are thinking about this question of creating trust in AI. And so, give us a sense of how you perceive differences among the technical community that you've been a part of on this question, as well as the policy community, and what some of the policy community people that you've interacted with have advanced that might be different or at odds with tech folks in this area.
So surprisingly, maybe to everyone in the audience, the average MIT AI PhD student does not have a policy background. And I think like oftentimes I feel very frustrated by this aspect actually a little bit. As an academic, I would say first and foremost, oftentimes we get super siloed into these little shells of research that we do. And we end up being, we end up incentivizing our own work along the lines of what our community values. And oftentimes we forget what matters in the world and what doesn't. And so with respect to, I guess, having bopped around a few different places prior to actually beginning a lot of my research, I think it was really helpful to get a sense of what, from a political landscape perspective, from a funding perspective, from a interfacing with industry perspective, what were the questions that seemed to come up again and again. And over time, you realize that there is a common thread that unites a lot of these things. So trust in deployment of AI safety systems, how we think about adapting to users, how we actually care about these systems with respect to values and biases of the world that we currently live in. I would say that my own academic research agenda was focused or informed by a lot of this mentality. And so if anything, I almost wish that more academics would have taken more time prior to entering a research agenda to find what matters to them in a way that I think oftentimes when you start your career in a very focused kind of fashion, you forget about. And so, yeah, there are many, many similar questions that pop up spoken in different languages across all of these sectors. And I think it's fun to pull out what actually matters and what doesn't in the world.
Part of what you're doing, Elena, is, of course, bridging the technology policy divide all the time. And so just give us a sense of how that discussion might play out among private sector executives with respect to AI in emerging tech. I mean, what level of technical fluency on AI in particular, but any new, I guess, piece of software or any new element of your cloud computing business that you want to integrate, how much technical knowledge do you or your minders, your leadership at the board level, need to understand about these issues? Where do you go for information on this? Help us just understand on this question of bridging the divide, your relationship in the technical community as it relates to law and policy.
Well, thank you, Ted. From my experience, I found that the technical knowledge across the corporations, different leadership levels, it varies. There are some boards that are very, very well aware of the implications of technology and AI, and they ask the right questions and they guide the company. And there are some boards that maybe, they might not be aware of the full implications just yet. But I think what's really important for all of the technical leaders, the high level leaders, is to understand at least the basic fundamental questions that we've been discussing, right? To understand that a lot of tasks that are very difficult for humans are very easy for computers, and vice versa. And of course, when we develop technology, when we put new technology out to the market and introduce those new tools, we should be guided by the ethical principles. We should be guided by those frameworks. As I mentioned before, the benchmarks and the frameworks, they do lag behind the technology. So a lot of companies are just left to their own devices, so to say, to develop those guiding frameworks for themselves. But at least some of the key questions to consider, before starting development or putting in new products to the market, and I've noted them here for myself. So for instance, what is the problem you're trying to solve? What is the potential for bias? What data sets and models are you using? What is the review process? What are the ethical guidance that the teams are following? How are we ensuring the privacy of the users? How is the security of the systems ensured? If a threat actor infiltrates a system, what is the response that companies have in place? And what is the potential damage they can make to the system? So those are just at least some of the guiding questions and principles that I think executives and the board members could be using to guide those questions. But definitely, I think the wide recognition of the potential is definitely there, and it's a matter of embracing and having the right frameworks and tools. In terms of where do we go for information, Ted, I would say a lot of the data sets that companies are using, they're using their own data. But definitely, very happy to see if there's anything or better partnership that we can be using and building with the academic community. If there's something that you think we can, work on joint research projects, that's definitely something that we're very open. But I think a lot of companies, they do have the appetite to stay proactive and would be very open to new ideas.
Thank you so much. I want to open this up to questions and comments from all of you, and we'll start right here with Kelly. Did you have something? Oh, yeah. All right. Great. We have some folks online too. Just briefly introduce yourself and press the button.
My name is Kelly. I'm an undergrad in Yale College in Computing in the Arts. I just want to direct this question at Elena. You mentioned that in terms of building trust, there's an issue that a lot of people fear that automation is taking away jobs. And I was wondering if you could comment on that, especially in the context of, I think, in February, study came out of Yale and UPenn talking about how automation is fueling increasing mortality among US adults due to kind of deaths of despair, and kind of how you mentioned that doesn't necessarily have to be the case, how we can kind of work through that.
Interesting. I haven't seen that report, so if you can send me, I would be very interested to take a look. In terms of the link between automation and jobs, I think there were, of course, fears that were present, but what we're seeing right now in the workplace, is actually the opposite. We do know that that automation is the future of cybersecurity, and that's the only way for us to keep up with the evolving threat landscape. And yet, at the same time, as I mentioned, 3.5 million jobs are going unfilled completely. So we actually are not seeing that, a lot of those fears come to life in our industry. As a matter of fact, what we're seeing is that AI create new opportunities for workforce to move away from mundane, very tedious tasks to being more creative, to thinking about more complex problems. At least this is the implication for our industry. And, definitely, it's up to us to create those new types of economic opportunities for the workforce. And this is what we as business community are doing.
Thank you. Want to get some online questions?
Yeah, I have two questions that I think are connected enough to present them both to you all, and let you decide how to parse them out among you. So one question is about what types of expertise might be used to identify bias in AI. And a related question, I think, is the following: as AI becomes more powerful and independent, is there a risk that it might develop a totalitarian bias versus more humanitarian bias of human intelligence? So I wonder, both kind of questions, looking at both bias, what kinds of bias might be developing, and what are some tools and techniques for addressing that bias?
Want to start with that one, Andi?
Yeah, a question as fundamental as how do we solve AI, I think, but I think an important one to specifically identify. So I think, and you'll hear about this from Brian in the next session, I think a key question we as a field are grappling with right now is the question of alignment, which is how do we align the intended objectives of our users with those of the actual systems that we have trained, which is actually a question that's incredibly hard when you think about it from a technical perspective. So I guess I will motivate this with a pretty dumb example that I think is pretty illustrative. So one of the earliest examples of a cleaning robot, like prior to Roomba, there was a robot that was yet worse than Roomba, that we more or less trained to suck up dust. The programmer said, hey, I want you to suck up as much dust as you can in the next 10 hours. And so they train the robot learns to vacuum up dust. And then they put the robot in a house. And can anyone guess what is something the robot might have done that we didn't want the robot to do?
I know the answer, I think.
Yeah, Ted, what's the answer?
Is it created more dust?
That's right. The robot sucked up dust, dumped it out, and then sucked it up again, because this actually maximized the number of dust, the amount of dust it was able to collect. And so in this very specific example, this was a pretty dumb but illustrative failure of how when we're designing systems, despite our best intended efforts, we don't actually get the desired effect. Because from a program perspective, transmitting or me as a human putting my intent into what I want the system to do is actually an incredibly hard problem. And so when we talk, before we even get into the questions of bias and how do we think about mitigating, intended or unintended biases, communicating what we want is already a hard problem. Now you kind of interact that with the fact that the data we're training on might itself be unclean, and you've got all sorts of bad effects that go on here. And so I would say this is a really fundamental core question to a lot of key areas of AI research that are currently breaking. And I think when we can tackle that question is when we as a field are better able to actually like AI, shall we say.
Thank you. Let's get a few more questions from the audience. Yes, just briefly
Sure.
identify yourself.
Hi, I'm Joe. I'm a master's student at the Jackson Institute. One question I have about AI and especially its public sector applications is about the idea or the feature that the answers that an AI system might provide are not interpretable. It's hard to account for how the machine learning or how the AI came up with that answer. And one possible solution strikes me as to if I were a politician accountable for a decision that was made using AI, if I had to explain the way that decision was made, could I do that? And is there any way that AI might in the future be able to demonstrate the decisions it makes, or would that undercut AI entirely?
Drago, do you want to maybe comment on this question of how to, any research that you've seen on this question of explainability or transparency, or is it a fool's errand, which might be where the question was getting at?
I wouldn't be surprised if it's a fool's errand. However, there is a large community in the AI world and computer science world that works on explainable AI. For example, if you understand the model that was used to train and to generate the data, you can figure out what features it has learned about the data. For example, does it look at, I don't know, facial expressions or the way that people speak, and then be able to say, I made this decision because of this and this and this thing that I noticed. At least, you know, in this case, you can decide whether those are legitimate things that should have been considered in making the decision. It's a very difficult problem. I think that most of the AI these days, including those pre-trained language models, is more or less of a black box. So people do study the behavior of those black boxes. They probe them. They try to see what they really know. For example, very recently, there was a very interesting paper where people tried to probe how much math pre-trained language model understands, and they ask it questions like, how much is 5 plus 5? 10. Then they figure out that it actually understands very simple arithmetic quite well, but then you give it the question like, how much is 10,905 plus 10? And at that point it fails, and there's really no reason why it should fail. It's a very simple arithmetic operation. It's just that the model, the internal model, is not designed in a way to generalize. So this generalization capability is still missing. This also applies in logical reasoning. For example, you can teach, computers syllogisms, how to reach certain conclusions for certain premises, but they don't know how to generalize this to arbitrary case. They may not even be able to recognize that that's the same story that they have already been trained on.
Thank you. Elena, do you want to also just maybe comment on this question of the explainability, the trust from a trust perspective, right? At what level would you be comfortable in your organization, making decisions based on an output that you may not be able to interpret?
Yeah, thank you, Ted. I would say that explainability is actually one of the fundamental elements of our AI ethics policy. So definitely a transparency and explainability is there. We also expect that that component will become part of the regulatory frameworks or guidelines that we're seeing, from the side of the different institutions. So the EU has already developed AI ethics guidelines that they're asking companies to follow. Interestingly, last month we saw the news from China, and it could be interesting for just the research community. They're also asking companies to be able to explain their AI models. That's a new development as of just last month. And of course, so a lot of the innovation in the AI space is emerging in EU, US, or China. So those are the just geographies where we see a lot of those regulatory frameworks, and explainability is a core part of that. I'd also, Ted, want to just address examples of how we can fight biases in AI. So, of course, the very well-known bias is that a lot of assistants, voice assistants are by default programmed as female. So we know that, knowing that, we've actually tried to put it upside down. And we have 100,000 employees globally. As I mentioned, we have unlimited internship opportunities open and many job openings in our sector. So with that comes the opportunity for a lot of meetings and interviews and just candidate interaction. So we have automated a lot of the interview scheduling and interview interaction. And our recruiting AI by default is actually male. So this is not a female. And this is, probably just an example of how business community being aware of the biases can really, stay ahead of that and equal the playing field.
Thank you. I see Scott, Professor Shapiro.
Hi. Sorry about that. Just addressing Elena's comment about the AI policies. So I totally see, because you're chief trust officer, why you would want explainability, because how do you say trust this thing that's not explainable, but that doesn't answer the question about whether the policy can be satisfied. So the question then becomes like, we can say you really need to do this, but if it's not doable, then it feels like I went trying to fool people. I'm not saying it because you say like, oh, we have these policies, but these policies are not actually implementable.
Right.
And so like, I was curious what you thought about.
Yeah, so Scott, in cases where it's not explainable or it's not clear, what companies do is they put a human at the end of that chain to make a decision. So then, then you have the actual person who took responsibility and signed off on this. So we call it human in the loop, just the chain. And this is, if there's a better way that researchers can figure out how to do it, we'll be happy to listen. But that's, I think, using a human, that's the best that we have right now.
So the answer to fixing artificial intelligence is human intelligence.
That's right.
Yeah.
Or both, both. Yeah.
Right. Okay. And that's a totally cool answer.
Yes, please, and we'll get you in the back. Did you have someone online? Okay, we'll get you.
Hi, I'm Rachel. I'm an undergraduate studying computer science, and I've also researched AI safety and robotics at Yale. I'm interested in the topic of regulatory frameworks because, as Drago identified, some key areas of solving issues related to ethics fall in the domains of individual responsibility in identifying fake news or other related ideas, which a lot of psychology research shows that belief change is incredibly hard, specifically in the area of fake news. So I'm skeptical of that approach. And similarly, in terms of putting the responsibility of incorporating fair and safe AI on businesses, I'm also skeptical because the nature of AI models in businesses is very proprietary. And that leads to a lack of transparency, which in my opinion leads to a lack of trust. So I'm curious from those of you who have worked in the domain of the public sector and regulatory frameworks, what you see as the biggest barriers to implementing things like the AI Accountability Act and other related state legislature.
Want to take that, Andi? You've had some interesting public sector experience.
It's very administration dependent. So when I was at OSTP, I was there in 2018. And I would say kind of the key valence surrounding how we talked about issues of AI regulation was oftentimes regulation meant the curtailing of capitalism in its finest form. Now, I think since 2018, in the last 3.5, 4 years, the conversation has shifted. Where now, I think with the catastrophic failures of a few public, largely traded technology companies, I think the key to regulating AI safety has come down to an issue of identifying how the actual intended audiences or demographics of the companies themselves ought to be enforced to not fail, if that makes sense. So it's almost saying like by our regulation, we are providing a helpful framework for you to understand how your product might fail. And so if anything, you ought to work with us from a public sector side and identifying what those might be, because we have the expertise to help you to choose what those might be in a way where maybe technologists on the ground don't. And so I think by kind of winding the two conversations together, it becomes more of a team united effort towards identifying how we collectively can tackle the issue of AI deployment in a safe way, rather than thinking of it as like an adversarial relationship. And so I think from a personal experience perspective, that's probably the way moving forward.
I can add to that.
Yeah,
Absolutely.
go ahead.
So Rachel, in addition to regulatory frameworks, what you might be interested to take a look at is the contractual law, because a lot of the times when as a user or as a customer, you put your data in the cloud systems, a lot of companies, including ours, they say this data is only going to be used for performance and capacity planning. So it's not going to be used for any other purposes. That's not intended to use, and that's actually written down in contracts. So just sticking to that intended use principle is very important, and that's going to be another source of frameworks that will be guiding that trust aspect.
I want to get some of the online questions, and I'll end with you.
Yeah, I have a couple. They're not necessarily particularly connected, but I'll present them because I think they go to different panelists. So one is a question which we often get. It's worth connecting it to this conversation is whether and how quantum computing might affect the risks that we've been talking about today. And then a second question is really, I think, mostly aimed at you, Elena. As a global company, do you find the concept of trust has a cultural component? Does it change across the world? So we were hearing about the question of kind of the cultural and issues with machine learning relating to natural language. Do you see kind of similar kinds of challenges in terms of building trust globally? You mentioned you have 100,000 employees globally from multiple different cultures. How does that affect both trust within the company and outside?
Thank you. Drago, any thoughts on quantum computing real very briefly? And I'll just add that Quantum Week at Yale is the week of April 10th. So there's actually 20 plus events happening across the campus and the law, technology, policy elements of the campus, including some events that Jackson is hosting. Dr. Mark Ritter of IBM's Physical Sciences Council, I think on April 12th. So stay tuned for that. But yeah.
You got me here. I'm not very familiar with the way quantum computing works. However, as you said, there is a very big quantum computing initiative on campus. One of the new faculty hired in computer science, Yongshang Ding, is an expert. You probably want to ask him. He just joined us from the University of Chicago. Now, as far as I'm concerned, I'm just as skeptical as John Feigenbaum, who talked about this in one of the previous meetings. I'm very skeptical this is something that will be important in our lives in the near future. As I think Elon Musk said, it's about worrying about overpopulation on Mars. That's how much I'm concerned about.
Trust across cultures.
Yeah,
Elena.
I would say, Ted, I think looking back into the future, and I don't know how far into the future, whether it's 10 years or 15 years from now, I do think that quantum computing will be transformative. I myself, of course, am in a business world, but I love innovation, and I hold 35 granted and pending patents, and some of them are on quantum computing. So if you want to have a more detailed discussion on that, happy to do that. To Ona's point, culture is a critical element for us. We actually have a board level initiative on culture in our company. So, there's a huge number of efforts that support that, from internal training awareness efforts to how we work with customers to foster that. And in just 2 weeks, I'm myself participating in the first Chief Trust Officer Forum, where we're going to be discussing just that. So it's exciting to see the industry evolving and changing.
We'll get a final question here, and then I'm afraid we'll be out of time.
I'm David, an undergraduate studying global affairs. I think we've talked a lot about the disconnect between policymakers and the law and AI practitioners and researchers. So the way I'm trying to understand it is almost like a spectator who's not familiar with a sporting event trying to follow along, like just wanting to double click on how big the disconnect is. Is it kind of like a spectator doesn't understand the strategy and tactics of the game? They might understand the strategy, but not the tactics. So I guess, for example, in football, are policymakers asking, are we going to throw a field goal today? Or are they asking, are we going to score a touchdown this way, if that makes sense?
Andi, I'll give you the last word on this just because you've been in both of these worlds. How far off is the divide in your experience?
It's pretty far. I mean, not surprisingly, I think. That being said, I think there are folks who have started working in connecting that gap, bridging that gap, which is, I know, an oft parroted term, but I think like truly in the last few years, we have seen attempts towards doing so. in fact, like personally, this was a motivating aspect as to why I wanted to even do this thing called a PhD, right? Like I felt like I did not understand the tools and methodologies that were available enough to policymakers to truly make policy on it. And so it feels like from a technical perspective, it's worth investing in understanding how does an entire research field and community think about these questions and what are the actual like tools in one's toolkit available to address these issues. And I think when you kind of have built a foundation like that, and I think I would encourage more of us to think about doing so, it better informs the way that you think about how you can deploy, I guess, policies and strategies in practice. So disconnect is big, it's getting better. I also think we should invest in educational opportunities and or speakers and or teaching that allows for this to be closed more.
Please join me in thanking our panelists. All right, please take a break, stretch. There's some coffee and snacks outside, and we'll get started at 10:30 promptly, featuring Scott Shapiro and